to learn some math.
Alright, now it's time to talk about Euler's formula and nets, okay? Your learning target is I can apply Euler's formula to find the number of vertices, edges, and faces of a polyhedron, and I can use nets to analyze three-dimensional figures. Alright, let's go. So before we begin on any of this stuff, we're going to first kind of talk about what the makeup is of a three-dimensional figure, okay? Three-dimensional figures are made up of three different things, okay? Each flat surface in a 3D figure is called a face, okay? We can see right over here each flat surface, three-dimensionally flat surface is called a face. So on this little shape here, we can see we have a face on the top, we have a face on the bottom, and there's four faces that kind of make up the sides, right? Okay, now the line, back up here, the line made by the connection of two faces, okay? So this line made up of the connection of where two faces kind of intersect, that's called an edge, okay? These are called edges. So we've got an edge here, an edge here, an edge here, an edge here. There's edge, edge, edge. There's a whole bunch of edges in this shape, right? And then finally, a vertex, which this is probably the one that you guys understood before we even started here. The vertex is the point at which three edges, or you can think of it as three faces, come to the exact same point. And we see here's a vertex, there's a vertex. Each one of these outside points is called a vertex, okay? Now a net is a diagram. We use this diagram of three-dimensional figures, and what it does is it shows all the surfaces of the figure two-dimensionally. Okay, what that helps us to do is that will help us to calculate surface area later on when we have to do that. But for now, we're just going to use a net to kind of identify what three-dimensional figure we're looking at. Okay, so in order to identify a 3D figure from a net, we need to look at the number of faces and the shape of each face. Okay, look at the number of faces and the shape of each face, and if we do that, that will help us understand what three-dimensional shape we're actually looking at. So this is a net, example one. Both of these are considered a net. And we want to describe what three-dimensional figure is made from the given net. Okay, so first let's go ahead and identify how many faces are there. Okay, so how many faces are there? And we can see each one of these sections here is representing a certain face of the three-dimensional figure. It's kind of like you have paper outlined, and if you fold these things all together, we make some sort of a shape. Okay, so how many faces there are? We see that there's going to be 5 faces. And we need to identify what are the shapes of each of those faces. And we see we have 3 rectangles, 3 rectangles, and we have 2 triangles. Now the easiest way to identify what type of shape we're going to be using is, first of all, if we're using straight edges like these, we're going to be talking about either pyramids or we're going to be talking about prisms. If we have circles, we're going to either be talking about cones or cylinders, right? So we have straight edges, so we're going to be thinking about prisms or pyramids. Now remember, prisms have 2 bases. Pyramids have 1 base. And we can see here, there's 2 triangles, 3 rectangles. Those 2 triangles are going to be the form of both bases. So we're talking about a prism here, and we can see that, remember, a prism has parallelograms as the side. Rectangles are parallelograms, so we're going to be talking about a prism. And because our bases are triangles, this is a triangular prism. And if I were to cut this whole, if I were to actually cut this out and I were to fold at each one of these lines here and I connected them by like taping it all together, what we'd see is we've made a triangular prism, okay? This second one over here, again, there's 1, 2, 3 faces this time. 2 circles, and there is 1 rectangle. And so we have to identify, because we have some circles here, we have to identify, is this going to be a cone or is this going to be a cylinder? And remember, cones, they have one base that goes up to a common vertex. Okay, right here there's one rectangle, but those circles are our bases. The circles are just always going to be the base, and because there's two of them, we know that that's going to end up being the form of some cylinder. Okay, so this is actually a cylinder. That's going to be a cylinder. So essentially what we're trying to do is look at the faces, look at the shapes of those faces, and if we can kind of identify based on the rules and properties that we talked about from last video, that helps us identify what three-dimensional figure that we're actually talking about. Alright, now we also got to talk about Euler's formula. Okay, and first, before we do that, let's kind of identify what a polyhedron is. Okay, a polyhedron is formed by 4 or more polygons that intersect at their edges. Okay, so let's think about that. We've got it says a polyhedron is formed by 4 or more polygons. Okay, so if I were to tell you choose from the following list of prisms, pyramids, cylinders, and cones, which one of those two would be considered polyhedrons and which two would not be considered polyhedrons? From prisms, pyramids, cones, and cylinders. Pause the video real quick, take a second and try to figure that out and fill those blanks of what you think. Okay, take a second. Alright, so I hope that you took a second and you actually did pause the video. If you haven't, do it now and take that guess. But what you should have gotten is that pyramids and prisms are considered polyhedrons, and cylinders and cones are not considered polyhedrons because polyhedrons have polygons. Cylinders and cones have circles, and those are not polygons, right? That's one side. Polygons have to have 3 or more sides. So let's go into Euler's formula, though. It says Euler's formula says that for any polyhedron, remember that's 4 or more polygons connected at edges, with V vertices, E edges, and F faces, the following formula will be true. If it is truly a polyhedron, then this formula will be true. So let's do some examples of that. Example 2 says find the number of vertices, edges, and faces for each polyhedron and use your results to verify Euler's formula. So first, let's go ahead and identify the vertices, which is vertexes, right? Edges and faces. And we want to know what are the number of each of these. So vertexes, how many vertexes are there, or vertices? If we count these out, we can see this is a point. So 1, 2, 3, 4, 5. And then the next ones are on the other side, 6, 7, 8, 9, and 10. So there's 10 vertices. Edges are, remember, where 2 or more faces come and intersect with each other. So we've got an edge right here. We've got 1, 2, 3, 4, and 5. There's going to be also 5 on this other side, right? 6, 7, 8, 9, and 10. And then we've got some edges on these sides right here. There's 1, 2, 3. There's going to be one right here. 4 and 5. So there's 5 more. So that brings our total to a total of 15 edges. Okay, and then let's identify how many faces there are. There's 1 and 2. There's 2, one at the top and the bottom, and then there's going to be 5 around. So 3, 4, 5, 6, and 7 different faces. Okay, and we can use Euler's formula to actually see is this a polyhedron, right? Remember, Euler's formula is V minus E plus F will equal to. Okay, we just have to substitute these numbers in here. So V, there's 10 vertices minus 15 edges plus 7 faces. That should equal 2. And if we solve this, 10 minus 15 is a negative 5 plus 7 equals 2. Negative 5 plus 7 is 2. And so we see that that does check out. That is verified. We verified Euler's formula then. So we could see that with example 2, it's somewhat easy. As long as you count correctly, it's fairly easy to solve that type of problem. But sometimes it's going to want us to tell how many, if we have a polyhedron, how many are we missing, right? So again, let's write out Euler's formula, V minus E plus F equals 2. And this one says that there is a polyhedron. It has 6 faces and it has 7 vertices. We want to know how many edges does it have. And so we can use this formula to see how many edges it has. All we have to do is plug in these numbers. There's 6 faces, so we're going to put 6 in for F. There's 7 vertices. And we want to know how many edges there are, so we're going to leave E as our variable and just solve for E. And if we do that, we'll be able to see what or the amount of edges that there are. So first we can combine like terms. These two constants, 7 plus 6 is 13. This is 13 minus E. Remember, we can do that because of the commutative property of addition. It says that the order doesn't matter. And then 13 minus E equals 2. We just have to subtract 13 from both sides. We get negative E is equal to negative 11. And then just multiply by a negative 1 on both sides. And we end up getting that the number of edges is equal to 11. And that's how we do it.